Hello class, thank you for joining me. This is Mr. Ish. Today we'll be talking about functions in terms of transformations, translations, and reflections. It's an important topic when it comes to graphing functions and understanding how one function can be converted, or that same function can be converted to another merely by moving it around. So if you're talking about a function f of x is equal to, let's just say x, f of x is equal to x, and here I do not mean the linear equation line y is equal to x. Imagine x can mean anything, just for the purposes of this. And one of the more important types of modifications of a function is if you have a coefficient before x. Let's call that coefficient ax. F of x is equal to ax. If supposedly a is a coefficient and it happens to be some value larger than 1, you're going to have a graph which will be steep in terms of its incline. It'll be steep, or it will be vertically stretched. And I'm gonna try to make sure my handwriting is good. So if the coefficient a before x is some value larger than 1, it's going to be a steep vertically stretched graph. If supposedly a happens to be something smaller than 1 but larger than 0, so here we're talking about like fractions like 1 over 2, 1 over 5, 1 over 10, something which is a fractional number, it will not be steep, but it'll be vertically, well, you can say it'll be, I was going to say vertically shallow, but you can also say it'll be horizontally stretched, because that would be the opposite of vertically stretched, would be horizontally stretched, and I'll just abbreviate horizontally stretched, and I'll be showing you this in terms of graph, what it means. If, however, a happens to be like a minus number, well, we'll be reflecting that same graph along the x-axis. We're going to reflect it downwards. So if something looks like a letter U, you put a minus a, it's going to look like an upside down U. And a positive means you're not reflecting it at all. No reflection. Not reflect. So that's just in terms of the coefficient a. A affects the stretching of the graph. So let's look at another form of translation or transformation. I'm going to erase this part, and I'm going to add over here x. Well, let's just keep a over here, but we're not going to modify this a, and we're having something called plus and minus k. Now we're talking about some type of translation. Plus and minus k means is something moving upwards, is the whole graph translating without any other change, but it's just moving upwards. If it's a plus k, it's going to move upwards. Whatever k can be like a 1, 2, 3, 4, whatever units, that's how many units it'll move up. If it's a minus k, it'll move that many units down. So we're talking about here vertical movement up or vertical movement down. And let's look at a horizontal movement. And these movements we're talking about are called translations. You're translating the graph. Now I'm going to parenthesize this x plus and minus h. See, h here stands for a horizontal shift. If you have a plus h, you're going to be shifting something. Now this is going to be a little opposite to what you would think. You're going to move something towards the left. Now likewise, if you have a minus h, if you end up having an expression with the x minus a value, it's going to move that towards the right. The plus h is towards the left. That many units that we're talking about. You can also have a combination of these two effects, a vertical and a horizontal. X plus and minus h will be using only one sign. You wouldn't have both, plus and minus k. So in these cases, something is moving horizontally right and left, and something is moving vertically up and down. And if you end up affecting a, you can have something, in addition to these horizontal vertical translations, you can have vertical stretching or horizontal stretching. And if you have a plus and a minus over here, we can end up having something reflect upward or something reflect downward. So you can have a whole combination of translations, transformations, and this sign here which implies reflections. The best way to picture all of this is using an example. And I'll use a parabola as an example because that's the easiest way of picturing this. Again, the simplest parabola is f of x is equal to x squared. F of x is equal to x squared, and here if there's no coefficient written, it's always understood to be 1, so a would be 1. But let's just write ax squared. This would be a graph assuming a is a 1, a regular, not so steep, not so horizontally stretched, but a regular parabola. Now let's replace the a with a coefficient something larger than 1. Remember, a large coefficient means vertical stretch, meaning you're making something steeper. Let's say 2x squared. What would a 2x squared look like? If this is ax squared, where a means 1, a 2x squared would be vertically stretched. So everything in terms of y, in terms of the rise, is higher. So that's an ax squared, that's a 2x squared right over here. And this right here is just a simple x squared with a coefficient of 1. What if this were a fractional coefficient? If we made that half, now we're going to horizontally stretch the same function. Now we're going to horizontally stretch it. See, it's being horizontally stretched. It's no longer compressed, but it's being stretched out. So this looks like a half x squared. So that's just in terms of looking at the modifications of a. These are like the various transformations. You can do the same thing, but now if you're talking about reflections, if you put a plus, this is understood to be a positive, but if you put minus over here for any of these transformations, you'll have your basic minus x squared over here, because now we're reflecting everything down along the x-axis. Here's your minus 2x squared. It's steep, but it's pointing downwards because of this reflective minus sign. And then here's your minus half x squared. Again, horizontally stretched, but pointing downward because of this minus sign. So these are the transformations and translations related to the sign and the a coefficient. Let's talk about some translations next, using the same parabolic example. And I'll write again f of x is equal to x squared. I'm not bringing in a coefficient over here because always it's understood to be a 1 unless otherwise. So let's make our plot. Let's make a vertical translation. This would be the plus and minus k aspect over here. If you're saying x squared plus 2, this here is our basic example of an x squared function. But x squared plus 2 means you're shifting it up by 2 units. It's the same exact curve with the same breadth to it, and it's called a vertically translated parabola by 2 units. How about x squared minus 3? Well, this is a minus k, so it's going to be the same upward facing parabola because there's still a positive a over here, but it's going to shift down 3 units, having a similar stretch and compression to it, and it'll be x squared minus 3. So that's the plus and minus k effect, the vertical translation or the vertical shift. Let's look at the horizontal shift next. Here's a new plot. Horizontal shift, I'm going to put here a x minus 1. Remember, we would have a x plus minus h over here, the horizontal right and left shift. If you have a x minus 1, remember what I said, if you have a minus sign over here, it's going to be shifting towards this right. So we have the same graph of an x squared, but it's going to shift to the right by 1 unit. So if the vertex was here at the origin 0, 0, now the new vertex is 1, 0, but it's the same type of graph shifted by 1 unit because of the x minus 1. Remember, minus here denotes a right movement. And we have a square here. If supposedly we have f of x is equal to x, let's say plus 3 whole square, you could have something after here, a positive a here, of course. Now we're going to have the same type of graph, but we're going to shift it 3 units to the left. 3 units to the left. So the vertex now has become minus 3, 0. Same type of graph, but shifted to the left 3 units. So you have x squared in the middle, and then you have x plus 3 whole square shifted to the left by 3 units. Let's show an example with multiple effects occurring. Let's look at this. We have an x plus 4 whole square and this, a minus 1. We have a horizontal shift to the left by 4 units, see a positive here to the left, and we have a vertical shift down by 1 unit. The coefficient a here is of 1 and is a positive, so you're not going to have any compression or stretching over here, but you just have shifting going on. So it's going to move 4 units to the left and it's going to move 1 unit down. So your vertex is now going to be minus 4, minus 1, and you'll just have a regular parabola from there pointing upwards. That's your parabola, and then you know this right here is your line of axis or the line of symmetry. Let's look at yet another example. we'll put in a transformation over here. Now we have a minus, and then let's say x minus 3 whole square plus 4. You know, the basic standard of a parabola is always f of x is equal to a into x minus h whole square plus k. The horizontal shift, the vertical shift, and any compression or stretching or reflection reflected here in terms of a. So we have a parabola that's going to point downwards simply because we have a minus sign. It's going to reflect downwards. We have a movement to the right by 3 units because we have a minus 3 here. It's going to shift to the right. We have a movement upwards by 4 units. So what's our vertex going to be? Our vertex is going to be 3 comma 4. 1 2 3 and then 4 units up. 3 comma 4 is our vertex, and we're not being very accurate over here in terms of intercepts, and it's going to point downwards. And like I said, we're not being very accurate here with our intercepts. We don't know what these x-intercepts are. You can calculate them by solving for x in terms of this entire equation. But this right here is your graph of this. Shifted down, shifted up 4 units, shifted to the right 3 units, and pointing downwards because of this minus sign. Lastly, we'll look at one more example. F of x is equal to minus 1 over 2 into x minus 1 whole square, I should make that x plus 1 whole square, minus 1. We know our basic parabola is an x squared. Well, here we know we have a change in the coefficient, a change in the sign, a horizontal shift, and a vertical shift. All we have to do is just picture it and then draw it. We're moving to the left by 1 unit. The positive sign to the left by 1 unit. We're moving down by 1 unit. The minus sign, this is a minus k. We're reflecting downwards, and we're going to horizontally stretch. Remember, we have an a value here, which is less than 1, but it's greater than 0. It's a fractional number, so it's going to be a horizontal stretch of that graph. So let's plot our vertex. It's going to be minus 1, comma, minus 1. That's our vertex. We're gonna have a broad parabola because of this denominator. It's going to be a broad, horizontally stretched. Let's draw a line of axis. You don't have to do this, but I'm doing it. And it's pointing downward simply because of the minus. And what would the basic x squared look like? It would look like this right here. So you can see with these additions over here, these transformations, translations, and reflections, you've drastically altered the appearance of this function. So again, transformations, translations, reflections was the purpose of this lesson. Easy to understand and grasp. Just remember h, horizontal translation, plus and minus k representing the shift upwards and downwards, a representing the horizontal stretch or the vertical compression, and the plus and minus sign in terms of the reflection, whether it's reflecting upwards or reflecting downwards. Graphing calculator can easily help you with this, or a lot of practice and you can begin to visualize them very easily. Thank you for joining me. I hope you all subscribe to my channel and give me a chance to keep continuing with these lessons. Have a nice day.